Alrighty, in this video we are going to put together the client class as well as the concept of a room. So I said earlier we're going to have these rooms such as the lobby or an individual game, and each room has a view, and whenever that view changes based off of our diff function, we're going to submit a diff to a set view diff or a merge view action with the diff to all of the subscribed clients so that they can stay up to date. So we're going to start this video off by hopping into server shared actions, and we're going to set up some view actions. So I'm going to create another section. I'm going to do this here at the top of the file, right before user actions, and I'm going to create a section called views. So we'll have one action called merge view, which when the client receives a merge view event, then it'll, well, merge the view. And then we're going to do a export const merge view action factory that's going to take in a view, a diff, and an ID with the default of undefined. And it's simply going to be type merge view, and then our diff, and then our ID. Then I'm going to create another factory function called setView. And setView will take in the view's data, and an ID of undefined. But what it'll do is it will pass itself into merge view and pass along most of the parameters, such as view. But instead of passing in the diff, it's going to pass in an object with a money set property set to data, and then finally the ID. So the set view still dispatches a merge view. The only difference is the set view will replace the entirety of the view because the diff has the set property. Remember that we have special handling in our diff.js file. If the set property is present, then the entire tree of that hierarchy gets replaced. Now let's go ahead and create our 4 view constants. So export const view app is going to be view app. That view is going to contain global data, such as what sets are available. You could also maybe use it to dispatch, like maybe site-wide messages or something, or the server's going down or something like that. Export const view lobby. She should, not much to say about that. It's just the lobby view. Then the view game. And then the view player. Now, the view player, the player class is going to be created by the games and is going to represent each player. The players themselves will be rooms, but the only clients that are going to subscribe to each individual player object is the client that player represents. So that when the view player sends its view, it will only get sent to the one client that it's responsible for. So with that, let's go ahead and jump in. Let's make room. I'm going to go ahead and create a folder under server called lib. And inside of lib, I'm going to create a file called room.js. And we're just going to go straight down here. I'm going to say, I'm going to import Lodash, first of all. Then I'm going to import star as a from backpack actions. Remember, these are the server actions. Now, I haven't yet created this file, but this file is, the actions file on the server is going to export everything from the shared actions, but also add some server-specific actions, just like what we did with the client. So before we move on with Room, let's go ahead and create that actions file. So I'm going to go ahead and directly on server, I'm going to create a file called actions. And he's first of all going to export star from shared actions. So he's going to export everything from the shared actions. And then in the future, we'll add server-specific actions here. Anyway, jumping back into Room, remember, export star from shared actions, and that finishes that file for now. Jumping back into Room, I'm going to import make diff and is unchanged from backpack shared diff. And then I'm going to export class RoomBase. Now, he's going to have a property called view, but this is going to throw a new error saying, please implement a view. The way we're going to use RoomBase is we're going to inherit from it. And the way that each inherited room class is going to export its view is by providing a override of this property. But if you don't provide an override of this property, then it'll throw an error at you. So we're going to have a constructor with the view ID, and we'll say this ID equals undefined, this underscore view ID equals view ID. This underscore inTick is going to be false. This last view is going to be empty object, and this clients is going to be an array. So we'll see what intick does here soon. Last view is how it's going to determine what changed between the two operations. And then clients is an array of all the subscribed clients. So first of all, we want to do an add client. So the add client function is simply going to say this client's push client, but then it's also going to say client.emit a.setView, this view ID, this view, and this ID. So the client object itself, which we'll see later, is actually going to be a dispatcher. And anytime you submit an action to that client, it'll be sent over via socket.io. Then I'm going to return a function. And the function is just going to do lodash remove this client's with a match of ID is client ID. So the function returned by add client is how you would remove a client. Then I'm going to do a broadcast function that takes an action, and all this does is simply says for let client of this client's client.emit action. So it's going to loop through all of the clients and then emit that action to everyone who's subscribed. Now, here's the most important method, and that is _tick. Anytime that you want to make a change to a model, you wrap it in this tick. And what the tick is going to do is it's going to execute that action and then check to see what values changed from the view, and if there was a change in the view, to broadcast that view change to every subscribed client. However, I don't want to nest ticks. So I'm going to say if we're already in the tick and it has an action, simply invoke that action and return null. So if we're so ticks will not get stacked. You can continuously tick over and over and over again in the hierarchy, but only one main tick will actually perform the diffing. Then I'm going to say this in tick is true. I'm going to say if action. I'm going to say try action. And then finally, this in tick is false. So try to invoke the action. If it fails or succeeds, reset our in tick to false. Then I'm going to invoke this dot post tick, which will be a method that you'll be able to override. And then I'm going to say this, well, I don't have to say in tick is false anymore. Now I'm going to say const new view equals this dot view. So the idea is that the view every time is going to get a new object. Then I'm going to say const diff equals make diff based off of our last view and then our new view. So that'll make the diff. And I'll say if diff is not is unchanged, then this dot broadcast a dot merge view, passing in our view, which is our view ID, and then our diff, and then our ID as well. Then all I have to do is say this last view equals new view, and then return diff. Then all I'm going to do is write an empty post tick function. So classes that inherit from this can use the can hook into the post tick function to execute code after the action's been generated, but before we've made the diff. And that's our room. So let's I'm going to scroll up to the top here, and then scroll down. And that's all really there is to it. Now, before we write the client, let's put together an example room. So in model, I'm going to create a file called application.js, and he's going to import our actions. He's going to import our dispatcher. He's going to import the RoomBase. And he's going to, well, he will be importing a lobby here in a moment, but we're actually going to leave that for last, and when we actually write the lobby. So I'm going to say export class application extends RoomBase. Now, if you make a room, you have to have a view. And the only thing that the application view is going to do for now is set our sets to this.sets, or this.cards.sets. So that this .cards property is going to point to an instantiation of our card database. And then the sets property of that is going to return an array of all the available sets. So this is how clients are going to be aware of all the available sets. Then I'm going to write a constructor that's going to take in cards. It's going to invoke the super constructor with an a view app for the view ID. Then we're going to instantiate a dispatcher. This will be the application-wide dispatcher on the server. So different models can hook into this dispatcher to get server events if they want to. Then I'm going to say to do make lobby. Then I'm going to say this cards equals cards. And then, actually, that's it. Maybe move that to do down. So once we actually write our lobby class, we'll be able to instantiate it here. And that's the application, with the exception of instantiating the lobby. So now let's go ahead and write our client. So in model, I'm going to create a new folder called client.js. And I'm going to go ahead and import our actions. And then I'm also going to import dispatcher. And then I'm just going to leave it at that. I'm going to say export class client extends dispatcher. So this is kind of interesting. Every client is going to be their own dispatcher. However, what they're going to do is when you emit to a client, it's going to take that action and send it through socket.io to the client-side code. And then if you do an on request on the client, you'll receive an action that was dispatched by the client code, by the actual web page. So let's start off with a get details function, or property. Details will simply say ID is going to be this ID, is logged in is going to be this is logged in, and name is going to be name, or this.name. Then for our constructor, we're going to take in two things, a socket from socket.io and our app. Our instantiation of the application class. The first thing I have to do is invoke the super constructor of dispatcher. Then I'm going to set this ID equals socket.id. This.isLoggedIn equals false. This.name equals null. And then this.app equals app. Then I'm going to store a reference to the socket. This underscore socket equals socket. And then what I'm going to do is I'm going to say this underscore on dispose, or how about on disposes, equals empty array. Now this is going to be an array of functions that are going to be invoked when the client becomes disposed. And we'll use it immediately right down here, because I'm going to say this.ondisposes.push, and then I'm going to push app.addClient this. So this way, we're adding ourselves to the application room to get the global details about sets, and then we're pushing that function that will unsubscribe us from the application onto our onDisposes array. Meaning if this client disconnects, for example, it will automatically unsubscribe. Then I'm going to go ahead and say this.emit, and I'm going to use an action we haven't written yet, a.user, or we have written, user details set, passing in this.details. So we're going to tell the client about this. Now we haven't hooked up our dispatcher implementation into socket.io yet, so right now this line of code will do nothing, but it will do something here in a second. So now let's go ahead and do socket.on action. Action goes into super.emit action, and then socket.on disconnect goes into this.dispose. So this is how we hook it up to where if we dispatch an action to this client. Actually, I do want to... no, I don't need to do that. If the socket, if the client code, the website, sends an action through socket.io, it will be emitted onto this client dispatcher, so anyone who's listening will receive that action. Now, it's important to do super.emit, not this.emit. The reason is we are going to be actually overwriting the emit function. Before we do that, I want to preemptively do one more thing. I want to do this underscore install handlers. And we'll write that function, but it'll just be blank for now. Anyway, so now that we've done that, we have to make it so if we send something to the client, that it gets then sent over socket.io to the website. So we'll say emit action. So we're overwriting the dispatcher emit function, and we're changing it to simply this socket.emit action action. Now, between this line of code and this line of code, we have now hooked Socket.io into our dispatcher implementation. So we'll be able to receive actions from the client, and we'll be able to send actions to the client. All right, let's go ahead and do our dispose. Dispose is simply going to say for let on dispose of this on dispose. I mean, alternatively, you could write it this underscore on disposes dot for each. A goes into invoking A. Either one would work. And then we'll set our on disposes to empty. And that's actually it for now. So here's our client. You can just scroll through that. Obviously, we'll be adding more code to this class later. Now let's go ahead and hook in the client with the application. So I'm going to go into server.js, and we've already imported Socket.io as a package. As you can see, we have Socket.io 151. So all the way at the top of server, I'm going to start off by importing it. So that's going to be up here. I'm going to say import Socket.io from socket.io. And then I'm going to set it up down here in the setup tag, and I'm going to say const io equals socket.io server. This will hook in socket.io to our HTTP server. Then I'm going to also import our application and our client. So I'm going to import client from model client, and I'm going to import application from model application. Then I'm going to scroll down to services, and after we instantiate our cards, I'm going to say const cards app equals new application, which should be this because I can spell good. And I'm going to pass in the cards database. Then I'm going to write another section called socket. And inside of socket, I'm simply going to say io.on connection. Socket goes into new client socket cards app. So every time we get a connection, we'll instantiate a new client class, passing in our internal Socket.io socket and the cards app. So the last thing to do is to go ahead and hook up the client so the client's using Socket.io. So let's go into client, client.js. Let's scroll up all the way to the top, and let's import io from Socket.io client. So import io from socket.io-client. Then, in my services, I'm going to create a Socket.io service. I'm going to say const socket equals io, and then I'm going to add it to my services object. Then, all I need to do is, after the print action, I'm going to say socket.on action. Action goes into dispatcher.emit action. And this is how we hook in Socket.io into our dispatcher. If the server sends an action event, we will just dispatch it. So now the server can send us actions just arbitrarily, and all those actions will get processed by our stores. And with that, let's go ahead and test it. So I'm just going to open up a new tab here, and let's go ahead and open up our developer tools and see if we got anything interesting. And if we look, we'll see we get our lobby join event and our lobby join success. But then we get a merge view. And the merge view has a diff of set of the sets that are loaded. So this is coming from the application room. So yeah, that seems to be working just fine. We also get our user details set as well with our ID that came from the Socket.io ID. I am noticing that our merge view actually might have a bug in it. So let's take a look at that real fast. For merge view, we pass in, I never pass in the view ID. So make sure that you pass in the view ID as well as the diff and the normal ID and then the merge view type. So with that, I should be able to refresh, and I should get object merge view, a view of view app, and then a diff of the view. And that means it's working. So with that, we'll see you guys in the next video.